Hey, welcome everybody to 8.1 Exponential Growth. Just so you know, in Chapter 8 we're going to be talking about exponential equations and also about the inverse of exponential equations, which are logs. So we're going to be spending some time graphing these, and then we're going to spend time solving them at the end of the chapter. Today our goals are to graph exponential growth equations and then also to use exponential growth equations in real-world problems, such as like, if I have $1,000 in an account, how much money am I going to have after 10 years at 8% interest? I'll talk more about that later. Alright, so an exponential function, it looks like this. Y equals a times b to the x. That's the general format. And today we're going to be talking about when the b value is greater than 1. If the b value is greater than 1, that's what gives us growth. Alright, just to kind of show you what the parent function, or just kind of like a general function for exponential growth looks like, we're going to plot a bunch of points, but when we actually graph later, we're not going to plot as many. So just to start off with, this is an example actually, not a parent function. I'm going to have f of x equal to 2 to the x power. Remember, f of x is just a fancy way of saying y, so that doesn't change anything. Here's what we're going to do. To make our graph, we're going to create a table of values. I already have some x values chosen for us. So we're going to go through and fill in the x value to find y. So remember, when I have a negative exponent, it turns into 1 over 2 cubed, which is 8. And so what I'm going to do here is just go ahead and fill in this chart. If you want to, just pause and try it on your own first. Just every time, remember, a negative exponent equals 1 over that. So that's where I'm getting some fractions here. Alright, I'm going to keep going. 2 cubed is 8. Alright, and then I'm going to graph the points I have. So it's kind of tricky. Just do the best you can when I get to these really small numbers, but I got negative 3 comma 1/8. Again, just do the best you can. Negative 2 to 1/4, negative 1 to 1/2, 0 to 1, 1, 2, 2, 4, and 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so here is what an exponential growth equation looks like. Now, the two easiest points to find on this are always the y-intercept and then the point where x is 1. So when we make our graphs later, we're just going to graph those 2 points and then draw in the general shape. Two things I want to point out. First, the domain and range. So if you look at this, if you think about the domain, that is the x values again. Think left to right, x values. Okay, if I made the world's largest graph here, all x values would be used. So my x values are all real numbers. And now for the range, you can see, when I look in the y direction, you can see that all of the values I've got so far are above 0. So we just kind of have to ask ourselves, do we think that it's going to go below 0? So just think about it for a little bit. If I tested some numbers here, I'm going to get some really small numbers and really big numbers, but none of them are ever going to go negative, and none of them are ever going to go to 0 even, actually. So our range is y is greater than 0, not greater than or equal to, because it's never going to be 0. So that's the first thing I want to mention, is that the domain and range, domain is all real numbers, range is y is greater than 0. And then I want to show you something as well here with this tail end. Notice how as we get closer and closer and closer this way, or further and further this way, I mean, it gets closer and closer and closer and closer to this line here that I just drew in. That's actually called an asymptote. And before I find the equation for this asymptote, I have a section right here for you to write this down. So the equation of the asymptote, it's an equation of a line, and the graph I have approaches the line but never touches it. So it approaches the line but never touches it. Alright, and here we have to remember that a horizontal line has the equation y equals a number. How I remember that is that it's going through the y-axis, so it's going to be y equals whatever number it's going through. In this case, it's going through 0, so my asymptote is the equation of the line y equals 0. All right, so something that you may or may not have noticed is that when I'm doing a graph in general, let's write this equation down, y equals a times b to the x. It may already be on your sheet, but this number in front of the b to the x is going to be the y-intercept. And now actually this may not have been obvious, because if I go back to my original equation, it didn't have a value there. Really, it did. It was a 1. They just didn't write it. And that is why my y-intercept for this one is at 1. So the a value, or the number in front, is always a y-intercept, and if there's nothing there, it's a 1. And then the b basically tells us if it's going to be growth or decay. And also one thing you should know is that if a is negative, it's going to be flipped over the x-axis, but it's still considered a growth equation, which is kind of confusing. I'll say more in a minute, but if a is negative, the graph is flipped. Alright, so in general, here's how we're going to graph our y equals a times b to the x. We're going to first plot the y-intercept, then we're going to find another point, and really, you can find any point you want to. I just suggest that you use x equals 1 just because it's going to be the easiest. But really, you can find any other point you want to. After that, we're just going to draw in the general shape, and we're going to find the domain and range. That's it. All right. So when I did this form here, these didn't print very well. This one was supposed to be example 1, and here's what happened. It's going to be y equals 1/2 times 3 to the x. All right, step 1, find the y-intercept. Remember, the a value is the y-intercept. So my y-intercept right now is 0,1/2. Just do the best to graph it. And then step 2, find another point. Alright, so again, I could pick anything I want to, but I recommend using a 1 for x because it ends up being the easiest in most situations. So what that means is I take my equation and I'm going to put a 1 in for x. Use your calculator if you need to, but this ends up being 1/2 times 3, which is 3/2. So in my mind, I'm thinking 1.5. Alright, so I go ahead and graph that. And then step 3, draw in the general shape, because we know it's going to look like an exponential growth. And that's all you got to do for your graph. We also want to state the asymptote and the domain and range. So the asymptote in this situation, well, it has not shifted up or down. We'll be doing that later. So the asymptote has just stayed at y equals 0. And the domain and range are actually the same as we started with the one I did earlier. So the domain is all reals, and the range y is greater than 0. Alright, I want to next show you what it looks like if it's flipped over the x-axis. So for example 2, my equation is going to be y equals a negative 3/2 to the x power. Alright, step 1, find your y-intercept. And remember, if there's no number there, it's like a 1. In this situation, it's like a negative 1. So my y-intercept is at 0, negative 1. There it is, 0, negative 1. Alright, step 2, find another point. Again, you could find any point you want to. I recommend using 1 for x just because it makes it nice and easy. For example, right now, when I put 1 in for x, the answer just ends up being negative 3/2, and I didn't even have to use my calculator. So 1, negative 3/2. And you can see just naturally it's now going downwards, so it's going to go like this instead of up. And it seems weird, but that's still considered an exponential growth equation. It's just flipped over. Now this one, you can see the asymptote hasn't changed. So my asymptote is still at y equals 0. The domain is still all reals, but the range has now flipped. Because it's below the line, my range is going to be y is less than 0. All right, I'm going to give you the equations for example 3 and 4, and I want you to pause and try to graph them, and then we'll check your work in a minute. So the example 3 was supposed to be y equals -2 times 2 to the x, and example 4 was supposed to be y equals 2/3 times 2 to the x. All right, so pause the video and go ahead and try those two. All right, if you have unpaused, we're going to really quickly check your answers. So for example 3, your graph should look something like this. My y-intercept is at 0, -2, and my other point is at 1, -4. And for example 4, my y-intercept is at 0, 2/3, and my other point is 1, 4/3. All right, and for those, asymptote, domain, and range are similar to what we did earlier, so I'm not going to say that again. I'm going to talk a little bit now about how to shift these graphs. So you maybe basically feel like you're an expert at shifting graphs now that we worked so hard on the square root and cube root graphs in chapter 7. And actually the equation for this is very similar as what we did in chapter 7. So just like I did in chapter 7, I have a general format I'm going to use, which in this situation is y equals a times b to the x, subtract h, and the subtract h is in the exponent, and then plus k is not in the exponent. And the nice thing is that the rules are the same as they were in chapter 7. So in the exponent here, if you see a plus sign, it's to the left. If you see a minus sign, it's to the right. So remember, it's the opposite of what you expect for that. Outside of the exponent, if you see a plus sign, it's up, and if you see a minus sign, it's down. And now to graph our shifted equations, we're going to first graph the quote parent function. There's not really a parent function for exponential though, it's just going to kind of be the format without the shifts. And then step 2, we're going to move our asymptote. In step 3, move the whole graph. So let me show you that on the other page. So pause and write those down if you need extra time, and then when you're done, flip it over. All right, so here's 2 examples of shifting your graphs. First of all, let's identify what the shift is. So when I look at this, I see a minus sign in the power, so I'm thinking right 1, and then I see a minus sign outside, so I'm thinking down 4. And here's what I meant by graph the regular one. I'm going to first graph y equals 3 times 2 to the x, so no shift. And remember, think y-intercept, okay, so my y-intercept is at 3. To find the other point, I want to put a 1 in for x, and I have 3 times 2 to the first power. Okay, 2 to the first power is 2, times 3 is 6, so my other point is 1, 1, 2, 3, 4, 5, 6. And what I have just graphed right here is y equals 3 times 2 to the x without the shifts. So that is what I meant by step 1 on the previous page. So I just graphed the y equals a times b to the x without the shifts. And this step is optional. You are only graded on your final answer. So if you just want to put your final answer down, that's fine. All right, so step 2 on the previous page, I had said move the asymptote. Remember that our asymptote is normally at y equals 0. So when I'm moving my graph down 4, my asymptote moves down 4. 1, 2, 3, 4. And I do want you to draw in your asymptote to get full credit for your graphs. So make sure you draw in your asymptotes. So that's my new asymptote. Y equals -4. And now what I'm going to do is I'm actually going to shift my points also, right 1, down 4, but that's going to be my guide for drawing in the shape of the graph. So each one of these I'm going to move right 1, down 1, 2, 3, 4, right 1, down 1, 2, 3, 4. But the reason I wanted this asymptote line in here is that shows me how far to go with my graph. And if you're missing that part of it, you are going to get points docked. All right, the domain is still all reals. But if you look at the range, It has now shifted down 4, so I'm going to say y is greater than negative 4. That shifts with the asymptote. All right, tune in to part 2 to get the second example.